And in your book, you also mentioned crazy setups, like I think you mentioned a detector of the size of Jupiter orbiting a neutron star or something like that, and a particle accelerator of the size of the Milky Way. What are those things for?
So, if you naively try to estimate at which energy scale in a particle collision the effects of quantum gravity would become as strong as the effects of the other interactions, then you get something that's called the Planck energy. Which is like 10 to the 15 tera electron volt or something. And so the Large Hadron Collider, was it 10 to the 16? Well, something like this. And the Large Hadron Collider reaches around 14 or something tera electron volt. So there's like this 14 orders of magnitude gap between what we can presently do in an experiment and the energy scale that you would need to reach to produce an appreciable number of gravitons, say, so that you could actually measure them. And then there's the question like, what would it take to actually build a particle collider that could reach this energy? And this is when you get this estimate with the size of the Milky Way. This is assuming you use the technology that we currently use for the Large Hadron Collider. So you just scale this up. And the story with the detector the size of Jupiter is what size would a detector need to have to detect individual gravitons? And you can do that if you have a detector the size of planet Jupiter. If you put it in orbit around a neutron star and then you wait for 10 years, something like this, so you get all these completely ridiculous numbers. But as I was just trying to say, I think that these estimates are very misleading because there are entirely different effects of quantum gravity that are much easier to observe. So you don't necessarily need to actually produce or measure gravitons to find evidence for the quantization of gravity. It's like you don't actually need to detect single photons to find evidence for the quantization of the electromagnetic interaction. You can see this, for example, in the spectral lines in atoms, or just by the existence of atoms, basically. You need electromagnetism to be quantized. Otherwise, it just doesn't work.
Thank you for listening to this conversation with Dr. Sabine Hossenfelder. If you enjoyed it, please leave a comment below, like, subscribe, and turn on the notification bell. And please support this channel on Patreon. And thanks for watching.